Hello everybody. My name is Yair Alush. I'm working in the Cybersecurity Center of Excellence in Be'er Sheva, working for IBM. And what I would like to present today is a research project that we are working in the past year or so about a trusted and anonymized threat sharing platform using blockchain technology. Now, if it was 2017, I could have stopped the presentation now and leave the stage with your applause, but fortunately this is 2019, and today, when you would like to suggest a blockchain use case or a blockchain solution for a specific use case, you need to justify the benefits of the blockchain technology for this specific use case and make sure that those benefits really justify the cost and the complexity that's coming along with the blockchain technology. And this is exactly what I would like to do today. I would like to show you how blockchain can help to build a much more flexible and much more reliable and trusted threat sharing platform between organizations. But first, I would like to start with vision, what we called a next generation threat sharing network. I will focus not on the application, on the transport layer, but rather I will focus on the infrastructure of such network, about the networking layer of such threat sharing network, next generation threat sharing network. Then I will describe the current barrier for such threat sharing network. I continue with explanation why we believe that blockchain can address those barriers, and then I will describe our approach in IBM, how to resolve those barriers, and I will finish with some summary and time for questions. So what is a next generation threat sharing network? First, the next generation threat sharing network need to be more flexible and global. So today we have communities or trust group. Information is exchanged within CERT. Information is exchanged between FS-ISAC. But our vision that we would like to have a much more flexible and much more open network. The organization from different CERTs or for different ISACs will be able to exchange information. But we more than that. We want a network that will, for example, will allow security products like SIEM solution that will be able to interact with each other. And we want the infrastructure that we build to support also those type of networks, also those type of trust group. We want it to be fully integrated with the existing workflow of organization. We don't want to add other tools for sharing threat information. So we want that right-click on your data protection mechanism will allow you to share information with the organization that you trust immediately in an automated way. Another thing that we want, since we want to have a direct connection between organizations without the involvement of a trusted third party, we want to have a built-in anonymity. So we want to have the ability to share information on the one hand in a trusted way, but also in an anonymized way without the involvement of a trusted third party that need to anonymize the source of the information. When I will talk about anonymity, I will not talk about how to anonymize the data. We are not currently looking on the data, but rather I will focus on how to anonymize the source of the data, the organization or the entity that you are actually exchanging information with, that on the one hand you will have a trust, so you can trust this organization, but on the other hand, you don't need to expose your identity, and the other organization don't need to expose his identity. So let's start with example. What type of network or trusted network our infrastructure is designed to build? We would like that it will build. So envision a network of SIEM solutions, of SIEM appliances that are connected to each other. SIEM is a Security Information and Event Management. And envision a SIEM network in which organization can exchange, for example, the configuration of this SIEM They can also exchange log parsers of how they parse a log of a specific vendor. They can also share information about correlation rules, how to identify a specific incident. But the most interesting thing that this network can provide is it can allow the organization to share information about an incident. So envision that an incident in one organization will be automatically shared with other SIEM solutions of other vendors. And when those vendors, in case those vendors will see a similar incident in their organization, they will be able to see that this happened in other organizations and what happened, when it happened. Maybe they will be able to even open a war room together and start to exchange more and more information with each other. Trust can be established based on this data exchange, and maybe in the long term they can even exchange mitigation and strategies and so on. Another example that we want our infrastructure to support is envision a collective sticks report. You can look at it as a Google Doc in which different cyber analysts can build together and can work together on the same sticks report. So, for example, envision a network of cyber analysts that work together on a collective sticks report. The first analyst anonymously open the document and upload information, in this example, about some DDoS attack, about the threat actor that involved in this DDoS attack, and the malware that is using for the attack. And then another organization working on the same document, another analyst, sorry, uploads some indicators, for example, an indicators about the traffic with the command and control. Another analyst, another cyber analyst, sorry, is uploading another indicator, for example, about a registry key that indicating this specific attack, and so on. So different analysts from all over the world are working together on the same sticks report. Everyone is uploading his information in an anonymized way. And what we would like to have is such work will actually leverage the collective knowledge and the collective expertise of different analysts to create a unified document. The problem is that sometimes we have a different trust level between organizations. So envision that our platform will allow different organizations to have a different view of the same document based on the trust level that they have with each other. So it's not something that all organizations will be able to see the same version of the document, but instead, each organization, or in this example, each analyst will be able to see different version of the document based on the trust level that he has with the other analysts that contribute to this report. So this is a vision. This is a vision of infrastructure, of a platform that provides an infrastructure for supporting different type of threat sharing between organizations. So what are the barriers for such infrastructure? So the number one barriers for threat sharing today, this is according to a NIST report that was published about a year ago, is trust. How you establish trust between organizations. Even when we are talking with customers, the first thing that they say why they are not sharing more threat information is that just they don't trust. And when we are talking about trust, we need to talk about two-way trust. First, as a data owner, there is a trust that I want to make sure that only my information, my threat information, will only arrive to the right hands. And also, as a data consumer, I want to be able to trust the data that I consume, especially if I won't like to act upon this information. So we have a two-way trust. Another barriers is automation and interoperability. As I mentioned earlier, we want that that data will be shared automatically because everyone see and everyone understand the benefit of threat sharing. It was mentioned today, I think 3 or 4 times, the great benefits of threat sharing. The thing is that the benefit of consuming information is clear, but there is not really a benefit, usually there is not a clear benefit of sharing the information. So, and one of the ways to mitigate this problem is to make it easy to share information, to make it automated, and to make it integrated within the workflow. So what are the trust models today? So if we talk about trust, there are 2 types of trust models today. The first model is based on a trusted third party. This is the model that most of us know. For example, the Israeli CERT is a trusted third party. Organizations are willing to share information with the CERT, and then it analyzes it and distributes it back to other organizations. So this is one trust model, but it has its own limitation, mainly the scale that data can reach. The second trust model that we have today is based on a personal relationship. So for example, I know some WhatsApp group that used to exchange threat information between CISOs. This is based on personal relationship, but again, this is a very limited, and this is very far from our vision for the next generation threat sharing platform. Sorry. So this brings me to the main thing that I would like to present today. So why blockchain? How blockchain can help us in this use case? So the reason why blockchain can help in this use case is because blockchain is a technology that is designed to create a business network, a trusted business network when there is a complex relationship between organizations. Thanks to its distributive trust model, blockchain can allow us to create different type and direct trust group or direct networks of communication for exchanging threat information between organizations. It provides out-of-the-box benefits like transparency, so everything that is done or every protocol that implemented, for example, we have implemented a reputation system within our solution, a reputation system that associates each organization and actually in each record with a reputation score. Now, this reputation system, which because it runs on the blockchain, it is transparent to any other organization in the network. So anyone can know how this reputation is calculated and why it received this reputation score. Another thing that has come out of the box with blockchain is objective, immutable logging system, auditing system. So if, for example, you let the blockchain to monitor the data exchange between organizations, any exchange of information is monitored by the blockchain, and then organization will not be able to repudiate the fact that they have shared a specific information, or they will not be able to repudiate the fact that they have consumed a specific piece of information. This is things that are coming out of the box. But again, the main benefit of blockchain is that it changed the trust model. Instead of having a trust model based on a single trusted third party, thanks to its distributive trust model, it allows to create a different type of trust group, a different type of network. So for example, as I mentioned earlier, it can allow to create a trust group between ISAC members, FS-ISAC members, for example, or CERT members, but it can also create trusted group between specific SIM customers. The same infrastructure will be able to support all those different use cases. And this is exactly what I would like to show now. So what is our approach? How IBM is approaching this solution. So the first, the most important thing that is unique about our design is that we are separating between the blockchain, which is responsible for access management and supervising the data exchange, and the data and the mean in which data is actually exchanged. So data, the blockchain is used to supervise and monitor the data exchange, but the data itself is exchanging off-chain. And there are two reasons for that. The first reason is because if you exchange, if you put the data, the threat intelligence on the blockchain, it will be public. Everyone that has access to the blockchain ledger will be able to see the information. And obviously, this is not something that we want. So we want the data, we want to limit the access of the data between different organizations. So what you can do, you can obviously encrypt the data and store the data encrypted on the blockchain. But then this will yield to a very complex key management process in which only the rights, only organizations that are allowed to see the information will have the key, and this is highly complex. Instead, what we are suggesting to do is the blockchain, as you can see here, will produce a token, and we call it an access permission token, that can be consumed by other products, as I will see, that I will share later. And then data can be exchanged directly off-chain. The second benefit of this architecture is that you can use the existing means and the existing tools that you have today for exchanging threat information, and just to put the blockchain layer above it that will manage the access control. So for example, you can use taxi server for exchanging threat information, and the only thing that you need to change or to add for exchanging threat information is you need to put a proxy between the organization, between the user and the taxi server. This proxy will be used as a control point to ensure that only valid organization can access the information. And the proxy will be a blockchain client and will communicate with the client to verify whether or not a specific organization has a privilege to access a specific piece of information. Sorry. So we have described that we have, as I mentioned, we have separated the blockchain and the actual network in which data is exchanged. And what we have, on the blockchain, we have implemented a set of smart contracts. Smart contract is a computer protocol intended to verify and even execute a contract between two organizations. It's actually a piece of code that's running and making sure that running on the ledger and ensure that for any transaction, a specific set of operation will happen when this transaction occurs. So the first and most important contract that we have implemented is the registrar contract. The registrar contract actually is the bootstrapping of the network, and it regulates the creation of something we called organization profile or user profile, if you want. The organization profile or the user profile is a set of attributes that identify a specific organization or a specific user. Based on those attributes, the privilege of this specific, this profile will determine the privilege or the entitlement of a specific organization in the network. So in this example, a profile can include the following attributes. It includes who is the issuer of this profile. For example, it can be a cert or other entity that's responsible for adding a specific organization. It can include the role of this specific user in its organization, what sector, where the headquarters is located. Maybe if I'm a FSISAC member, it will also include this attribute. If I'm a Splunk customer, it also can include that. All those attributes will help us to create a very flexible type of networking of a trust group within the organization. So this is the main thing that is managed by the blockchain. So when you're talking about blockchain, you need to ask yourself, what is managed by the network? If it's just if it is just written on, just created by one entity, usually you will not need blockchain. You need blockchain when you have something managed in the ledger that is managed by several organizations. And the thing here about the profile is that this profile is not created by a single organization, but instead it can be created by a set of organizations. And the registrar contract is regulating who is allowed to write what attribute on the profile. So for example, if you think about the bootstrapping of the network, so we envision that there will be super organization in the network. For example, it can be different certs, it can be the different ISACs, or maybe other super organization that will be able to bring or to add a new organization in the network. Those are the issuer of the profile. Now, those organizations will know the real identity of the organization, but the profile will not include any information about the real identity of the organization. So it can add who is the issuer, what is the role, and other basic attributes about the organization. But other organizations, for example, IBM, can add to a profile of its customer the fact that an attribute that indicating that this specific organization is a customer of QRadar, for example, of IBM SIEM solution. Or it can, Splunk will be able to write on the profile of their customer an attribute that indicating that this organization is a Splunk customer. What are the benefits of this is another very important asset in the blockchain. We call it sharing and consumption policy. Here you can see an example of a sharing consumption policy. Sharing policy is basically a set of business rules that characterize which organization will allow to see information that I'm sharing. It provides me, as a data owner, it provides me a full control on the data that I'm sharing. Consumption policy, in an equivalent way, is a set of business rules that characterize from which organization I would like to consume information. Now, this is an example of a sharing policy. So, for example, I can say that, assuming that I don't trust a specific issuer, so I can whitelist or blacklist specific issuers that I don't trust. So so in this way, information that I'm sharing using this policy, data that I'm sharing will not arrive to any organization that in its profile, the issuer is in this blacklist. Another thing that, in this example, another condition that is, was set is that I can ask that the reputation will be higher than some threshold. Since we have implemented the reputation system built in within our blockchain solution, then everything, any policy can include conditions about the reputation of the specific organization. Another example of sharing policy is, for example, assume that I want to create a coalition or a trust group between ISAC members. So I can put two conditions. I can put, for example, a condition that declares that only ISAC members can see the information. And if, for example, I want to limit the information that I'm sharing, not with all ISAC members, but I want to limit it for a specific geo area, so I can, for example, say that only that I want that this information will arrive only to organization that the headquarters is located in Europe or in the US, so I can blacklist specific countries that I don't want the information to distribute. Another example is assuming that, this is going back to the example that we described in the beginning, is assuming that I want to create a coalition or a trust group of Splunk customers, so I can define a sharing policy that only Splunk customers can read my data, and I can also, for example, if I want my information to arrive only to a specific role in the user that holds a specific role in the organization, I can whitelist and blacklist here. So I think a good analogy to look on it is to think about, envision a certificate that includes different attributes about the profile of the users or the profile of the organization, and then you can have terms which, based on those attributes, which organization you can trust. Now, the second smart contract that we have implemented is called the relationship contract. What this relationship contract actually does is it takes the profile of the data consumer, the organization or the user that want to consume the data, and make sure that these consumers satisfy the sharing policy of the data owner. If there is a match, and also if there is a match between the consumer profile and the consumption policy of the consumer, then if those conditions are satisfied, then an access permission token will be generated, and then this access permission token can be consumed by any other blockchain client that is used as the control point between for exchanging information off-chain. So if we look on, if we return back to the example that we showed earlier, so for example, whitelisting on the issuer can create one network within the organization, while ISAC members, another sharing policy that limit the ISAC member will create another network or trust group between organizations, and so on. So to summarize, I hope that I managed to convince you that blockchain can help us to create a much more flexible infrastructure for threat sharing between organizations that is not based on a trusted third party and is not based on a personal relationship, but instead we shift the trust to the collective network that blockchain will create, and this distributive trust model will allow us to create a much more flexible networks and data exchange and interaction between different organizations. It can support many different types of use cases, not only using as a network for alerting, but rather to allow machine-to-machine or peer-to-peer direct communication between organizations, so data can flow directly from security tools that you have in one organization to a security tool that you have in another organization. All this is done in a trusted way because you trust the blockchain, so you can trust the relationship within the organization. It can also be done in an anonymized way because we don't expose the real identity of the organization. Instead, the only thing that is exposed is only the organization profile, which provides pseudo-anonymity for the organizations. Obviously, the key challenge here is how to reach the critical mass. Key challenge in any blockchain network that you are trying to build, and this is exactly what we are trying to promote today. IBM is currently running several pilots. One of them I can talk about is we have a pilot with the Israeli Ministry of Health that want to use this technology first to exchange information between medical institution in the first phase, between medical institution in Israel. But we hope that in the second phase, we can use the same technology. And as I've shown you earlier, this is exactly what our solution is designed to use this platform to exchange medical threat information between different hospitals all over the world, so to become more global. And we are working today with the partners to improve and to make the solution more robust. As I mentioned in the beginning, this is a research project, and we are looking for partners to collaborate on this domain. Here you can have my contact information if someone wants to collaborate or to have any question. Thank you.